Network protocols and standards. First, let's talk about protocols. Just like in human conversation, the various networks and computer protocols must be able to interact and work together for the network to communicate and for that communication to be successful. And a group of interrelated protocols that are necessary to work together are called a protocol suite. And these suites are implemented by host and networking devices in software, hardware, or both. So they're in different layers. One of the best ways for you to visualize how the protocols work inside of this suite and how they interact with each other is to look at the interaction as a stack. The example here on your right, you have your content layer, your rules layer, and your physical layer. They're stacked together. Protocol stack, like I said, shows how the individual protocols within a suite are implemented, and they're viewed in terms of layers, and each higher level service depends on the functionality defined by the protocol shown in the lower levels. So the lower layers of the stack are concerned with moving data over the network and providing services to your upper levels or your upper layers, which are focused on the content of the message being sent. As this example shows, you have your different face-to-face conversation going on, but there's other portions of your communication. You're using common language, you're waiting your turn to speak, and you signal when you're finished speaking. And then the content of that layer is the conversation itself. When humans talk, the communication rules are formal and others are simply understood. An example of that is you have this person here. At the human level, some communication rules are formal and some are simply understood based on the customs and the practices of the people that are involved. For devices, however, to successfully communicate, your network protocol suite, which are the protocols that work together to work across the network, must describe precise requirements and interactions. It tells the devices how to communicate. Networking protocols define a common format and a set of rules for exchanging messages between the different devices. Some of the common networking protocols are IP, HTTP, and DHCP, and you'll learn more about those as we go. Figure 1 here on the right tells you how the message is formatted or structured. You'll see that you have the gentleman that's sitting at the desk. He says, I will send this message across the network using the IPv4 header, and that is the address. And it says the switches and routers here in this particular example are routers, say I can forward the message because I understand the IPv4 header. And in that header it gives the sender and the destination information. The server at the other end says I can accept the message because I understand IPv4. If we move on to example in figure 2, the process here is by which networking devices share information about pathways with other networks. So they tell it where things live basically. Here we have, let us all agree that if one of our pathways is down, we will notify all the other connected devices. And that comes in play when, let's say, a particular line, this one here is the example, is down. All these other devices aren't continuing to look for path A. It knows it's down, so they don't even bother to go in that direction. Figure 3 is how and when an error system messages are passed between devices. Here we have an example where it says, where they're all agreeing that the error message will have a unique ID number. That way they can keep up with the different error messages. Here we have error 1002, which says path B is slow, and that is important. And error 1001 says that path A is down. If path B is slow, they're going to look for a faster method to travel. And in example 4 here, this is the setup and termination of data transfer sessions. So the gentleman here, he says, I would like to set up a virtual connection with you so we can exchange information. And the server agrees. He says we can now and send receive information between us. So they had to agree that they were going to communicate, and that agreement lasts for a certain period of time. More information here about our different protocols and our protocol stacks. I mentioned earlier HTTP, which is Hypertext Transfer Protocol. You have TCP, which is Transmission Control Protocol. You have IP, which is the Internet Protocol, and then you have Ethernet. Some of the other information to share with you on this is you have your application protocol. And basically that is your HTTP. And it's the protocol that governs the way a web server and a web client interact. If you'll recall, when you go out on the internet, your URL for different websites begins typically with HTTP. And the HTTP defines content and the formatting of the requests and responses that are exchanged between the client and the server. And both the client and the web server software implement HTTP as part of the application. And HTTP relies on the protocols to govern how the messages are transported between the client and the server. So it's its rules that it follows. The transport protocol, or the TCP, which is Transmission Control Protocol, is the transport protocol that manages the individual conversations between web servers and web clients. Your TCP divides the HTTP message into smaller pieces called segments, and your segments are sent between the web server and client processes running at the destination host. TCP is also responsible for controlling the size and rate at which messages are exchanged between the server and the client. Next we have IP. And IP is the Internet Protocol, and it's responsible for taking the formatted segments from TCP. It encapsulates them into packets, assigns them to the appropriate address, and delivers them across the best path to the destination host. So the TCP is dealing with segments, and IP changes it and starts dealing with packets. Next you have the Network Access Protocol. And the Network Access Protocol describes two primary functions. First, the communication over the data link and the physical transmission of data on the network device or media. And data link management protocols take the packets from IP and format them into to be transmitted over the media. The standards and protocols for the physical media govern how the signals are sent and how they are interpreted by the receiving client. An example of a network access protocol is Ethernet. So if it's going across the Ethernet media, it has to go in a certain order or a certain way. We do have different protocol suites and industry standards. A lot of times you will hear us talk about the TCPIP, particularly in this class, and that is going to have the HTTP, the DNS, your DHCP, and your FTP. You have your TCP and your UDP, your IPv4s, IPv6s, ICMPv4, ICMPv6, and then they all travel across Ethernet, PPP, frame relay, ATM, and LANs. You have ISO, you have AppleTalk, and you have Novell NetWare as well. And basically, your suite is your set of protocols that work together to provide comprehensive network communication services. And your protocol suite may be specified by a standards organization or developed by the vendor. AppleTalk is developed by the vendor. It is used on all the Apple devices. The protocols IP, HTTP, and DHCP are all part of the Internet Protocol Suite known as TCPIP. That's the one that you will probably use the most. Some of the protocols, like I said, are proprietary, such as AppleTalk. Novell NetWare is another proprietary protocol stack. When we're using data communication and we have to look at our different protocols, things can get dropped. If one is using a one-way communication and the other end is looking for a two-way communication, more than likely your data is going to be dropped. Now, several companies may even work together to create a proprietary protocol. It's not uncommon for a vendor or a group of vendors to develop proprietary protocol to meet the needs of its customers, and later assist in making the proprietary protocol an open standard. This is how we did develop several of our standards that we use in the industry now. Again, with our IP suite, it's a suite of protocols required for transmitting and receiving information using the internet, and it's commonly known as TCPIP, like I've said before. And the open standards-based TCPIP has replaced other vendor proprietary protocols such as Apple's AppleTalk and Novell NetWare. Both are still out there, but typically you're going to use TCP/IP. The first packet switching network and predecessor to today's internet was the Advanced Research Project Agency Network, or ARPANET, which came to life in 1969. Over to the right you have a timeline of when different things occurred. If you'll click on each of these blue buttons, or it's blue on mine, it will bring you up with some more information and kind of walks you through the different protocol suites, how they developed, where they live, where they've come from. Now, in today, the suite includes dozens of protocols. In figure 1 over here, you can click each protocol, and it's going to give you a little definition of what that particular protocol does. And this is a good study tool to help with the exam. It also helps you familiarize yourself with the information that we cover in this chapter, and that is the basis for the next several courses that you'll take in networking. The TCPIP protocol suite is implemented as a TCPIP stack on both the sending and receiving hosts to provide end-to-end delivery of applications over a network. Like I said, if they're different on each end, you're liable to have things drop. The 802.3 or Ethernet protocols are used to transmit the IP packet over the physical medium used by the LAN. Now, if we change to figures 2 and 3, they're going to demonstrate the complete communication process using an example of a web server transmitting data to a client. And all you have to do here to see how this works is you'll click play. So we click play and we watch the web server send out its page, and that is data. And from the user data, it then goes to the HTTP data. From there, it's going to travel to TCP segment. Then it becomes the IP packet. And then it completes the Ethernet frame. And that's the way that the protocol encapsulates and sends the information. So it went from the web server with all that information in it, and then it goes into the web client. here it has, it's gone to the web client. We have our Ethernet frame. We then look at the IP packet. It then is going to look at the TCP segment, then the HTTP data, and then the user data. So all of that is the IP packet. Okay? This is an excellent activity for you to complete. You're going to go through here and you will drag the function to the correct TCPIP layer name. And let's just grab this just as an example. I'll drop it over here. You'll do this with all of them, but as you go, you can click check and you'll see that, nope, that's not where it wanted that to be. So you can just drag it back, or you can do reset. So just practice this. Take these, place them where you believe they go. Check and see what your knowledge looks like on those. Okay, now that we've talked about network protocols, let's talk about the standards organizations that help us in developing the protocols and enabling all of our different devices to talk together. Open standards encourages competition and innovation. However, if everybody is doing their own thing, our computers may not necessarily talk well together or behave the way we want them to. So there are standards organizations in place that tell the industries what they expect to have happen so that we know how our devices are going to communicate, so that we can develop other pieces of equipment, peripheral devices, software, and we are all on the same playing field and we know what to expect. Some of the standards organizations are the Internet Society, you have the Internet Architectural Board, the Internet Engineering Task Force, the Institute of Electrical and Electronic Engineers, and you may hear that referred to as IEEE. You have the Internet Organization for Standards, or ISO, and each of these organizations will be discussed in more detail in the next couple of pages, just so that you know what they're about. Okay, the Internet Society is responsible for promoting open development, evolution, and Internet use throughout the world. It facilitates the open development of standards and protocols for the technical infrastructure of the Internet, and that includes the oversight of the Internet Architectural Board. So it is an organization within an organization, basically, that it oversees that. The IAB is responsible for overall management and development of the Internet standards. It also provides oversight of this architecture for the protocols and procedures used by the Internet, and it consists of 13 members. It includes the chair of the Internet Engineering Task Force. IAB members serve as individual and not representatives of any company, agency, or other organization. The IETF's mission is to develop and update and maintain Internet and TCPIP technologies. And one of the key responsibilities is to produce requests for comments, or RFCs. These documents, and what they are is they are memorandums describing protocols, processes, and technologies for the Internet. And it also consists of working groups. Their primary mechanism for developing the IETF specifications and guidelines. And these working groups are short-term, and after the objective of that group are met, the work group is terminated. They're no longer needed to take care of that task. The management of the IETF and the Internet Standards process is handled by the Internet Engineering Steering Group. Then you have the Internet Research Task Force, and it's focused on long-term research related to Internet and TCP/IP protocols, applications, architecture, technology. And while the IETF focuses on shorter-term issues of creating standards, the Internet Research Task Force consists of research groups for long-term development efforts. And some of the current research groups include Anti-Spam Research Group, the Crypto Forum Research Group, peer-to-peer research group, and your router research group. So there are different groups out there who are in long-term study of these different types of protocols. The IEEE is a professional organization for those in the electrical engineering and electronics field, which are dedicated to advancing technology innovation and creating standards. As of 2012, the IEEE consisted of 38 societies. It publishes 130 journals and sponsors more than 1,300 conferences each year worldwide. It has over 1,300 standards and projects currently under development. On the right here is a working group and study groups for the IEEE 802. You have 802.1, which is the higher level LAN protocols working group. You have 802.16, that's broadband wireless. So these different numbers you're going to need to at least familiarize yourself with. You don't have to know each and every one, but if they are mentioned specifically in your reading, you do need to make sure you understand and know what they are. An example would be the 802.3 and 802.11 standards. They are very significant IEEE standards in the computer networking. Your 802.3 standard defines media access control. That's your MAC for wired Ethernet. And the technology is usually for LANs, but also has wide area network applications. All your devices have a MAC address. The 802.11 standard defines a set of standards for implementing wireless applications across your local area networks, so your wireless local area network. And this standard defines the open systems interconnection, or the OSI physical and data link MAC for wireless communications. If you've ever bought a wireless receiver router for your home, it'll have the 802.11 and then it'll have a number on it, or a letter on it. You have the ISO, and that is the International Organization for Standardization. It's the world's largest developer of international standards for a wide variety of products and services. And the ISO is not an acronym for the organization's name. It is a term, and it's based on the Greek word isos, meaning equal. And the International Organization of Standards chose ISO term to affirm its position as being equal to all countries. In networking, ISO is best known for the Open System Interconnection Reference Model, and ISO published the OSI Reference Model in 1984. You will get very familiar with the OSI model as we go. It's kind of what our networking is based off of. Some of the networking standards involve several other standards organizations as well. You have the EIA, which is the Electronic Industries Alliance. You have TIA, which is Telecommunication Industry Association. The ITU-T, that's the International Telecommunications Union Telecommunications Standards Sector. You have ICANN, that's the Internet Cooperation for Assigned Names and Numbers. And then you have IANA, the Internet Assigned Numbers Authority, and it is a department of ICANN. You will be doing this lab. It is assigned in this unit, Researching Network Standards. And here is yet another activity in which this one you just click on what you think it's part of. As you see, I'm just randomly sticking dots in here so you can see how it works. And then you check it, and if you get anything right, then you understand that. If you get things wrong, then reset and try again. Now let's talk about reference models. There are benefits to using layered model to describe network protocols and operations. And using the layered model, it assists in protocol design, It fosters competition because products from different vendors can work together. It prevents technology or compatibility changes in one layer from affecting other layers. And it provides a common language to describe networking functions and capabilities. There's two basic types of networking protocols. You have your protocol model, and this is the model closely matches the structure of a particular protocol suite. The hierarchical set of related protocols in a suite typically represents all the functionality required to interface the human network with the data network, because basically that's what we're doing. The TCPIP model is a protocol model, and as you can guess, it's based off the TCPIP protocol suite. Then we have the reference model, and this is the model provides consistency within all types of network protocols and services by describing what has to be done at a particular layer, but not prescribing how it should be accomplished, just that it needs to be accomplished. A reference model is not intended to be implementation specification or to provide a sufficient level of detail to define precisely how the services are going to work. The OSI model that's listed here to your right is the most widely known inter-network reference model, and it's used for data network design, operation specifications, and troubleshooting. So in the OSI model, we have application, presentation, session, transport network, data link, and physical. And then in the TCPIP protocol model, you have application, transport, internet, and network access. It all works typically the same and has the same information being transferred. One just has more portions to it. With the OSI model, it was initially designed by the ISO to provide a framework on which to build the suite of open system protocols. Ultimately, the speed at which the TCPIP is based internet was adopted, and the rate at which it expanded caused the development and acceptance of the OSI protocol suite to lag behind. The OSI model provides an extensive list of functions and services that it can occur at each layer, but it doesn't tell you how it has to occur. TCPIP model layers are referred to only by name, and the 7 OSI model layers are more often referred to by the number rather than the name. For instance, the physical layer is referred to as layer 1 of the OSI model. So that's why here on the right you now have numbers. The physical layer protocols describe the mechanical, the electrical, functional, and procedural means to activate, maintain, and deactivate physical connections for bit transmission to and from the network device. And you can click through each of these to find out what each of these layers represent within the model. Make sure that you've gone through this. A simple acronym to remember how this works is you can start here at the P, and it is please do not throw sausage pizza away. Just little acronyms like that sometimes help, or mnemonics help you understand or remember the order that they go in, because you will need to know the order they go in. Next, we have the TCPIP protocol model for inter-network communications, and it was created in the early 70s, and it's sometimes referred to as the internet model. Here at each layer, here we have application, and it's going to tell you what it does. This you also need to understand and be able to reference. We can compare both the OSI model and the TCPIP model. As shown here to your right, we do have key similarities. The physical and data link layers in the OSI model correlate with the network access in your TCPIP model. Next, you have the network and transport layers of the OSI model. And network, just keep in mind, intranet, network. Transport is the same, transport. And then the OSI model has session, presentation, and application in what the TCPIP model refers to as application. Again, here is another activity for you to be able to work with. You just grab one and move it. Figure out where you think it may need to go. Again, I'm just dragging and dropping them. And you have the first one. You can play with it. Then you also have a second one. Here is the packet tracer activity and the lab activity.